Hey guys, sorry this video is kind of late to the game here. Had a busy weekend doing some stuff. So today and yesterday, you guys, we did some notes in class, but if you missed it, here is the video for it. So we are doing 2.1 inductive reasoning and conditional statements. So this is a little bit of 2.1 and 2.2. So first off, make sure that you do the warm-up. It's going to be a good intro to inductive reasoning and patterns, which is what we are focusing on for this, this lesson. So do your warm-up first, pause it, and then you can look at your answers. And I'm just going to, I would pause it and then check your answers. These ones with the pictures are a little harder. I am not the best at these, I will admit, but if you can figure it out, like obviously your drawing doesn't have to be perfect, but just try and figure those ones out. So then get out your notes or write it on a separate sheet of paper, but today you are going to be able to understand what conjectures and counterexamples are. You'll be able to identify and continue a pattern, and you'll be able to write a conditional statement and identify a hypothesis and conclusion. So first two definitions. A conjecture is an unproven statement that is based on observations, and then inductive reasoning is a process that involves looking for patterns and making conjectures. So you guys on the warm-up did inductive reasoning because you guys were looking there for the patterns, and then you were able to make a conjecture, which is that statement that is based on the observations that you made. So go ahead and pause it and write that down if you need to. Find the next two numbers in the pattern, then make a conjecture explaining why those numbers come next. So pause it and do these 4 problems. I'm going to go ahead and get them done. So for 1, 3, 5, and 7, it looks like I'm adding 2 each time. So my next two numbers would be 9 and 11. The conjecture would be add 2 to the previous number. With conjectures, you need to make sure that it is a statement. The definition is a statement. So it needs to be like basically a sentence. You can't just say plus 2, you have to make a statement. For number 2, from 100 to 99, we subtract 1, 99 to 97, we subtract 2, then we subtract 3, and a lot of you guys in class had a hard time explaining this. I'm not going to take off if you use your own words to explain this. How I explained it was, so this would be minus 4, then I'd have minus 5, and then minus 6. So the conjecture that we did was each time subtract 1 more than you subtracted the time before. You could also say you are subtracting each time by consecutive numbers, something like that. Like I said before, I'm not going to be a huge stickler on this. Just make sure that you use a conjecture. For number 3, 1 to negative 3, negative 3 to 9, 9 to negative 27. So you are multiplying by a negative 3. So your next two numbers are 81 and negative 243. And then your conjecture would be multiply the previous number by negative 3. Number 4, when you go down by a big number like this, like from 500 to 100, and then you go from 100 to 20, it has to be division, okay? So 500 divided by 5 is 100. 100 divided by 5 is 20. 20 divided by 5 is 4. 4 divided by 4 divided by 5 is 0.8. So the conjecture would be divide the previous number by 5. Find the 20th term in the following pattern. So this is where it gets a little trickier. So if I'm looking at this first one, A, B, C, D, E, A, B, C, D, E. So my first 5 letters or the 5 terms repeat. Okay, so you can do it the long way and you could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that would mean the 20th term is E. You could also think of it as, okay, so you take your term over your number in the pattern. So for this, our 20th term is what we're trying to find, and we have 5 numbers or 5 terms in the pattern. When I do this, I get a whole number. So if I get a whole number answer, it's the last term in the sequence. So I get a whole number here. That means that my term is E. Okay, the last term in the sequence. Make sure to write this down and this down somewhere. Okay, now for number 2, we have 2, 4, 6, 8, 2, 4, 6, 8. So there are 4 terms in this sequence that repeat. So I'm going to do 20 divided by 4. Now again, if your answer is a whole number, that means your term that you're trying to find, the 20th term in this case, is the last term in the sequence, which would be 8. And you could also count it out if you want. For number 3, I have 1, 2, 3 things that repeat. Square, triangle, circle, square, triangle, circle. Okay? So now this is where you're going to understand what why we do this division. So 20 divided by 3 is not a nice number. So I'm going to go ahead and do the next one. 19 divided by 3, also not a nice number. 18 divided by 3 is a nice number. It equals 6, so that means that term, the circle, is term 18. So then I'm going to count upwards. So in that case, my square would be 19 and my triangle would be 20. So the 20th term here is the triangle. And that's how we figure it out when we do not have a nice number there. So write this down. Counterexamples. An example that shows a conjecture is false. So when a statement that is made is false, a conjecture is a statement, is false, we need to make an example that shows that it's false. So in class, I had you guys raise your hand for this one, but if a GHS student is taking geometry, he or she is also taking chemistry. Tons of kids raised their hands that they were not taking chemistry. So the counterexample would be some students in geometry aren't taking chemistry. The next one, if the name of the month starts with the letter J, then it is a summer month. That's not true because there is January. January is not a summer month here in Indiana. If a number is odd, then it is not divisible by 2. So think of all the odd numbers. Can any odd number be divided by 2? The answer is no. So this conjecture here is true. So you guys try these next ones, pause it and write down your answers, or do the questions on your notes. These 5 that are coming up are there, and I'm going to go through these. So the product of 2 negative numbers is always negative. That is false. A negative times a negative is always a positive. So your counterexample, you have to write down an example. Adding a positive number and a negative number will always give you a positive number. That is false. If you have a really big negative number and you're adding it to a positive, then it's going to stay negative. The product of 2 positive numbers is always positive. That is true. A positive times a positive is always going to be positive. Next 2, all prime numbers are odd. Prime numbers are numbers that can be divided by 1 and itself. So 3 is an example, 13, 11, 23, 61. Those are all examples of prime numbers. But yes, they are all odd, but 2 is also a prime number. So that would be the counterexample here. If two angles form a linear pair, then they are supplementary. Linear pair, always their unshared side is a line. So a line, a straight angle, is 180 degrees, so that one would be true. Get these definitions written down. If you need to pause it, go ahead. A conditional statement is a type of logical statement that has two parts, a hypothesis and a conclusion. If-then form is a conditional statement that uses the words if and then. We always use if-then form in geometry for conditional statements. It always has to be if blank, then blank. So pause it and get those definitions written down. Hypothesis is the part of a conditional statement that comes after if. Conclusion is the part of a conditional statement that comes after then. Again, pause it, get the definitions written down. So we are going to underline the hypothesis here and circle the conclusion. If today is Monday, then tomorrow is Tuesday. Today is Monday would be the hypothesis. Tomorrow is Tuesday would be the conclusion. If I step in a puddle, then my foot gets wet. If I step in a puddle would be the hypothesis. The conclusion would be my foot gets wet. If an angle measures 180 degrees, then it is a straight angle. An angle measures 180 degrees is the hypothesis. Conclusion is it is a straight angle. Notice that I did not underline if and I did not circle then. Those are not part of the hypothesis and the conclusion. The hypothesis starts after if and the conclusion starts after then. Do not circle those or underline those on the tests or quizzes. You will get it wrong. You guys go ahead and try this, pause it, and do your answers. I'm going to do it right away because I'm kind of pressed for time here. If you are an American citizen, then you have the right to vote. If two lines are parallel, then they will never intersect. If a figure is a rectangle, it has four sides. If you want to be healthy, then you should eat vegetables. Okay, pretty self-explanatory, pretty easy. So when we write a statement as a conditional, sometimes we're just given a statement like this one, vertical angle share a vertex. The steps to write the statement as a conditional would be to identify the hypothesis and the conclusion, and then write the conditional. So make sure you get those two in your notes. Then write this down. From going from vertical angles share a vertex to if two angles are vertical, then they share a vertex. So we put that in a conditional statement. There. So go ahead and try these, pause it, and try them. On Sunday, I go to church. So if today is Sunday, then I go to church. We always have pizza for dinner on Monday. So you could do this two ways. You could say, if we have pizza for dinner, then it is Monday. Or you could say, if today is Monday, or if it is Monday, then we will have pizza for dinner. This one here makes more sense to me. Two complementary angles add up to 90 degrees. Again, you could do this in two different ways. If two angles are complementary, then they add up to 90 degrees. Or if two angles add up to 90 degrees, then they are complementary. The next slides, you can go ahead and do some more practice if you'd like, or if you're just trying to get your notes in, that is fine. And I would just pause it. But hopefully you guys understand. If you have any questions, let me know.